Hi everyone, welcome to Dento'ZEN. Today we are going to talk about the properties of dental materials. Why it is important to study them? Because if we are going to use these materials in the mouth, we should know that how they are going to behave and function in the oral environment. So that is why it is important to study these materials. So these can be physical or mechanical properties, but they are based on certain laws. For example, the laws of thermodynamics, thermal changes, the laws of optics, light phenomena, and the laws of mechanics. So the ones which are based on the laws of mechanics are known as mechanical properties, but they are actually considered a subset of physical properties only. So in today's video, we are going to talk about the three properties which are based on the laws of thermodynamics, that is thermal changes. So these are coefficient of thermal conductivity, coefficient of thermal expansion, and glass transition temperature. Now these three can come as short notes for your exam. So let's start. Before starting, quickly subscribe to Dento'ZEN, tap on the like button and hit the bell icon so that you remain notified about new videos. Now, all matter is made up of atoms. Atoms have central nucleus which contains neutrons and protons surrounded by the electrons. Now, how these atoms are arranged, based on that we can have crystalline materials in which atoms are arranged in crystal letters like this, or they can be non-crystalline where atoms are disorderly arranged. So some materials can be crystalline while others can be non-crystalline. But all matter exists in three phases, that is solid, liquid and gaseous states. So atoms are held in their positions because of the interactions between them and the energy of the molecules. So what will happen if there are changes in the energy of these molecules? If there are certain thermal changes from outside, then they can change the energy of these molecules and the interactions between the atoms, which can actually change their state. Yes, so one form of matter can change to other form of matter with the thermal changes. For example, liquids, when temperature is raised, they will absorb heat and they will change to gaseous state where the kinetic energy of the molecules will increase, and the heat which is taken up in the process is known as heat of vaporization. On the other hand, if the temperature is decreased, what will happen? These liquids will change to solids, and the heat which is released in the process is known as latent heat of fusion, and in the solid state the energy of the molecules will be less as compared to the liquid state. Not only that, solids can also change to liquid state with the intake of energy, and the temperature at which this happens is known as melting temperature of the solids. So whenever there are thermal changes, how that heat is passed through these solid substances, with that comes the first concept, that is coefficient of thermal conductivity. Yes, so conductivity is that how the heat is transferred, how heat is passed through a solid substance. So amount of heat that is transferred through a substance, the rate of heat that is transferred through a substance is based on two factors. So what are those two factors? First is the area, second is the temperature gradient. Gradient is the difference. So whenever there is heat flow, so what is the area perpendicular to that direction of heat flow, and second is the temperature gradient, that is difference in the temperature across the surfaces which are perpendicular to the heat flow. So we can say that rate of heat flow is dependent on area and temperature gradient. So that is how we can define coefficient of thermal conductivity, which is sometimes just called thermal conductivity, that is amount of heat transferred or thermal energy transport, thermal energy in calories per second through a specimen which is 1 centimeter thick. So specimen which is 1 centimeter thick with cross-sectional area of 1 centimeter square. So cross-sectional area of 1 centimeter square, and temperature differential between the surfaces of specimen, temperature differential between the surfaces of the specimen which are perpendicular to the heat flow is 1 degree Kelvin. 1 degree Kelvin. So that is the coefficient of thermal conductivity. So what is it? Thermal energy transport, calories per second, 1 centimeter thick specimen, area 1 centimeter square, and temperature differential of 1 degree Kelvin. So it is denoted by symbol K, and SI unit for this is watts per meter per second per Kelvin. Now, certain materials are good conductors of heat. They have high conductivity, whereas others are just insulators. They do not allow heat to pass through them, so they have low conductivity. Now, what is the significance? Metallic restorations which have high conductivity, metals are good conductors of heat as compared to the resin-based composites, so they will exhibit greater pulpal sensitivity whenever there are thermal changes in the mouth, because metallic restorations will allow more heat to pass through them, which can actually cause discomfort to the patient. More important for dentists is the linear coefficient of thermal expansion. That is the second important property here, that how much material will expand with these thermal changes. So how it is defined? So change in the length of the material per unit of its original length when the temperature is raised by 1 degree Kelvin. So that is known as the coefficient of thermal expansion. So this is given by formula where alpha is the coefficient of thermal expansion, delta L is the change in the length, divided by L is the original length, and delta T, that is change in temperature. So that is coefficient of thermal expansion. It is given in units ppm per degree Kelvin. And why it is important to know this linear coefficient of thermal expansion? Because it is different for different materials, and also it is different for dentin and enamel. So whenever there are thermal changes occurring in the mouth, because of mismatch of this coefficient, there can be problems. So let's get to know what is the significance. So restorations which are placed in the mouth, composite restorations, their coefficient is different from dentin and enamel. So whenever there are thermal changes in the mouth, there is hot or cold stuff, these restorations will contract or expand differently from dentin and enamel. So restoration contracts or expands more than tooth. What will happen then? A gap will come. Yes, for example, if this is the restoration, this is the tooth structure, because of more contraction of the restoration as compared to the tooth structure, so a gap will arise between the two, and that will lead to marginal micro leakage or even debonding of the restoration. Now, if we look at the inlay wax, it has very high coefficient of thermal expansion, 400 degrees. So it can show significant changes with thermal changes in the mouth. So inlay wax patterns which are fabricated on the dies or near the tooth surfaces, they can contract significantly when they are placed from warmer areas of the mouth or from the die to the cooler areas or the labs where they are stored. So the contraction in the wax pattern will happen, and these dimensional changes will be transferred to the cast restoration which is prepared from these wax patterns. So these cast restorations will then not fit into the patient's mouth. Similarly, denture teeth which are set in the denture wax base, which can again show alterations because of the change in the temperature where they are aligned and where they are kept before the formation of dentures, can lead to shift in the position of the teeth. Now, especially for metal ceramic restorations, because of the difference in the coefficient of porcelains and metals, so metals on cooling, the stresses may be induced in the porcelain, which can lead to delayed crack formation in the porcelain. So this mismatch between the materials cannot be completely eliminated, but it can be minimized if we fairly match the materials which have fairly same coefficient of thermal expansion. Now, here comes the third important property, that is glass transition temperature. As the word says, it is for glass. So glass is non-crystalline material, and it is very different from the solid substances because it has no definite melting point, but it gradually softens with the increase in the temperature. So with the increase in temperature, it gradually becomes soft. So the temperature at which there is an abrupt increase in the thermal coefficient of expansion of this material, indicating the increased molecular mobility, that temperature is known as glass transition temperature. So this glass transition temperature is always less than the melting temperature. So at this temperature, the hard material, solid materials will change into a soft material, a fluid state. So this is a property, this is given by TG, glass transition temperature, and this is a characteristic of glassy structures. So below this temperature, below glass transition temperature, the glassy structure will lose its fluid characteristics and will become resistant to deformation. Example is synthetic dental resins which may contain glasses. Now, why this glass transition temperature is important for us? Because it can actually determine the other properties like hardness of the material, and can also tell us that how these materials are going to behave in the ambient temperature. For example, certain materials whose glass transition temperature is well above the room temperature, so they exist as brittle polymers. So they are stiff and they have very low impact resistance at this temperature. Other materials where glass transition temperature is well below room temperature, they exist as soft elastomers and they can be easily stretched. Then there are certain materials whose glass transition temperature is close to ambient temperature, so they show plastic behavior at this temperature and they are strong and tough and they have high impact resistance. So certain substances like plasticizers are used where we want to reduce the glass transition temperature. So that is about the three properties of the dental materials based on the laws of thermodynamics, that is coefficient of thermal conductivity, coefficient of thermal expansion, and glass transition temperature. We are going to study more properties in our next few videos based on other laws. So don't forget to watch those videos. So like and share this video with your friends. Keep watching, keep learning, keep smiling, and see you in the next video soon. Till then, take care. Bye bye.